So we are going to call this Intro to Radians. Oh, it's frozen. Okay, my bad. Intro to Radians. Y'all remember learning about radians in Algebra 2? Nope. Probably you would have learned about it after we were on quarantine last year. So maybe I did, maybe I didn't. Who knows? But it's okay because I'm going to teach you as if you have not ever heard of it before in your whole entire life. So our target. What are radians? Does anybody know? And how do you convert degrees to radians and radians to degrees? A lot of lights on today. I'll just decorate one. All right, so we're used to measuring angles in degrees, right? That's how we always measured an angle. Well, an alternate way of measuring angles is by radians. And once we learn how to measure an angle in radians, that's pretty much what we're going to, how we're going to measure angles from here on out, in radians, not so much degrees. If you go on to take calculus, calculus AP, AP calculus, or anything like that, regular calculus, it's always in radians, okay? So you need to understand what a radian is and how to find it if you are given an angle measure in degrees. So let's first write, so we understand when we read our notes. We are used to measuring angles in degrees. And at the end of the year, I know I've said this before, I would recommend that you do not throw your free calculus binder away, but that you keep it in case you need to refer back to it. When you get to calculus, they're going to assume that you know certain things. And if you don't remember and you have your folder, your binder, you can go back and review it. Or if you're taking dual enrollment college math next year, keep your binder so you can go back and refer to it. Or if you're starting college next year and you're going to take college math or intermediate math, college algebra, use your binder. I know y'all don't believe me. I've actually had students email me who are in college and tell me that their binder helped them pass their class, their college algebra class, because there was so much stuff that we had learned, but they didn't remember, but they had that as a reference to go back and help them in future classes. So don't throw them away. Don't burn them. I know you're going to want to burn them. Don't burn them. Don't do it. Wait till you're out of college. All right, an alternate way of measuring angles is by radians. Also, I'm going to stop posting pictures of my notes. I'm only going to post video because I don't want you to just get the notes and write them down. Okay, most of you aren't, you're just writing what's ever on the page. You're not thinking about it. Like, where'd this come from? How'd you get this? What does this mean? You're just writing it down just to get it written down, right? If you watch the video, that's going to at least force you to have to hear explanations of things. And that's not why I make the videos, is because I want you to have, if you're absent or didn't understand, to have to watch them to understand the notes. So I'm just going to post the video instead of the video and the pictures of the notes. That makes sense? And it's not to harm you. It is to hopefully help you in the long run. All right, little geometry here. The arc, not that pen. The arc, ARC, subtends the angle theta in the unit circle below. The arc is the same length as the radius. So we would say the angle is equal to 1 radian. So the arc subtends the angle theta in the unit circle below. The arc is the same length as the radius. So we would say the angle is equal to 1 radian. Okay, well, let's draw the unit circle. And I'm going to put a point at the center of the circle. I'm going to draw the positive side of my x-axis. And then that angle that I created, we're calling that theta. Okay, so again, it says the arc subtends the angle theta. So the arc of the circle is opposite of angle theta. So we say that arc subtends angle theta, right? Remember geometry? Taking it back. It's saying that this arc is the same length as the radius. And what's the length of the radius in a unit circle? 1. So we're saying that the angle that we drew, say, pretend we took a piece of string. That's 1 unit. Okay. So we're saying that that arc is the same length as the radius. So we say that the angle is equal to 1 radian. So that is 1 radian. 1 radian. Okay. So let's say r equals length of radius. All right, let's draw another unit circle. So how many radians do you think it's going to make around halfway around the circle? How many do you think would fit? Think about 3? And remember, one's not perfect. So you're thinking about 6 all the way around, a little over 6. Very close. Do you know that, or are you just guessing? Just guessing. Draw another unit circle. We've got a center. Now I'm going to draw the positive side of the x-axis. So we were to start here on our initial side, okay, and we take the terminal side and rotate it all the way around the circle. And I went counterclockwise, so is that positive or negative? Positive. How many degrees is one full rotation? 360 degrees. Okay, so one full rotation. A rotation is a revolution around a circle is 360 degrees. Okay, that's great, but you said we were going to start talking about radians. All right, we're getting to it. We're getting to it. So let's talk about that. Or we could say 2 times pi times r. Y'all remember that formula? Okay. Well, what is our radius in the unit circle? 1. So let's change that to 2 times pi times 1, which would just be 2 times pi. And that would give us 2 pi is the radians. Radians, when you see pi, you know that the angle measure is in radians, okay? Because in degrees, we don't use pi, okay? So we also know that 360 degrees is equal to 2 pi radians. 360 degrees is equal to 2 pi radians. This is probably like weird right now. What in the world? How did you get that? I don't get this. I don't know. Just give me just be patient. Be patient. All right, let's look at the next page. Let's draw yet another circle. I've got to turn it down. It's getting hot in here. So, by the way, on our previous page, what do you think that 2 pi So we're going to kind of start learning about what degrees equals what radians. And some of them you're just going to know right off the bat, and then some of them you're going to need to convert. But the main ones you need to have memorized, okay? So let's start with 0 degrees. Well, how many radians do you think 0 degrees is? 0 radians. Okay, and we said that a unit circle, 360 degrees, equals how many radians? 2 pi radians. Okay, so if 360 degrees is 2 pi radians, what do you think 180 degrees would be how many radians? 1 pi radian, or we would just say pi radians. Because isn't 180 half of 360? So if I'm converting that to degrees, half of 2 pi would just be pi, right? Half of 2 is 1, 1 pi is 1. So what do you think 90 degrees would be? How many radians? Half. So pi divided by 2, we usually say pi halves radians. Pi halves, because it's pi divided by 2. 180 degrees is divided by 2 gives me 90 degrees. So pi divided by 2 gives me pi halves radians. All right, well, does anybody know the angle measure down here? 270 degrees. What do you think that is? Say it again. Not 1/2, but 1 1/2. So not 1/2, but 1 1/2. It's a whole pi plus another half of pi, right? 1 1/2. But you're not going to see it written as 1 1/2 radians. You're going to see it as an improper fraction. What is 1 1/2 as an improper fraction? 3 halves. So you'll see that as 3 pi over 2 radians, which we say 3 halves pi. All right. So knowing that 360 degrees is 2 pi radians can help us find 90 degrees equals how many radians? 180, 270. So those are pretty easy, and those are going to be ones you're going to memorize. So I say how many radians is 180 degrees? You're quickly going to say pi radians. How many radians is 90 degrees? Pi halves. How many radians is 270 degrees? 3 halves pi. So you need to memorize those. Okay. You can still use the conversion, which I haven't taught you yet, but we're going to be messing with it so much you're going to know it, no problem. All right. Well, now let's figure out. Okay, that's great. Well, what if we're talking about 45 degrees? How many radians is that? All right. So let's figure that out. Okay, so radians and degrees. Oh, by the way, what is pi approximately? 3.14 is pi. Notice 180 degrees is pi radians. Donald, how many radii did you say you thought could fit around a semicircle? You said it looks like 3, right? Well, pi is what? 3.14. So you were very, very close. If you would have guessed 3.14, I mean, I really would have lost it. But that's pretty close. That is correct. A little over 3 of our radii, if we picked our radius up and set 3 of them on a unit circle, and we were just going to 180 degrees, we would just be just barely short of 3 making the whole unit circle. 3.14 approximately radians on a semicircle. So, and you said about 6 would fit all the way around the circle, right? Well, 2 times 3.14 is what? 6.28. So just a little over 6 radii, if we laid them all the way around the circumference of a circle, would fit all the way around. Okay, pretty cool, right? 3.14. Okay, so let's talk about converting other things. So let's just remember that 360 degrees equals 2 pi radians. Right? We know that. We also know if we divide 360 degrees by 2 and divide 2 pi radians by 2, that 180 degrees will equal 2 pi radians divided by 2. That gives us pi radians. So we already knew that 180 degrees is equivalent to pi radians. Okay, well, if I want to know, okay, for 1 radian, how many degrees is that? So if I divided both sides of this by pi, then on the right side, pi will cancel out and leave me with radian. And on the left side, 180 degrees divided by pi is how I would find, if I said 1 radian gives me how many degrees. That's how I can convert it. Or if I wanted to isolate degrees, so let's go back up here, 180 degrees equals pi radians. Oh, I should have written more down. 180 degrees equals pi radians. I could divide both sides by 180, right? And degree equals pi radians divided by 180. So we're going to use these conversions to help us convert mostly from degrees to radians. Just like I said, once we know about radians, we really don't talk about degrees much anymore. Now, sometimes I still get confused on radians. When I'm given radians, I'm like, oh God, where is that? So a lot of times, even in my head, I will convert it back to degrees, and that helps me because degrees makes more sense to me than radians does. So sometimes, even though they give it to me in degrees, I'll still convert it in my head, or give it to me in radians, I'll still convert it in my head to help me with the problem if I get confused. Okay? So I'm going to teach you how to convert degrees to radians. We will use these formulas to help us. All right, so example 1. And like I said, tomorrow we will have an assignment on this. Today we'll just do notes. Because of course we're still ahead of second period because I see you all 5 hours every week. We're going to convert 30 degrees to radians. Okay, so we already learned on the previous page that 1 degree is equal to pi radians divided by 180 degrees, okay? So I want to convert 30 degrees. So I will multiply that by pi radians. And we know pi radians, so its equivalency in degrees is 180 degrees. So you're either going to be multiplying by pi radians over 180 degrees, or 180 degrees over pi radians. So this is how I remember it, okay? If I'm converting degrees, 30 degrees, if I made that into a fraction, degrees will be in the numerator, right? Well, I want the words degrees to cancel out. So I want to know radians. So I want degrees to cancel out my fractions. I need degree in the numerator of one fraction and a degree in the denominator of the other fraction. If the degrees were both in the numerator, they're not going to cancel, okay? So that's how I remember. It's either pi radians over 180 degrees or 180 degrees over pi radians. Those are equivalent. Pi radians is equivalent to 180 degrees, right? Hold on. Oh my goodness, got a lot of chats going on. All right, looks like I don't have a 10 here. Okay, so to simplify this, the words degrees cancel out, right? So when I multiply fractions, does anything else cancel out? No, but could I reduce 30 and 180? Oops. 30 goes into 30 once, 30 goes into 180 how many times? 6 times. 6 times. So I can reduce those. And nothing else can be reduced, nothing else cancels. So remember, when we multiply fractions, numerator times numerator, denominator times denominator. So on the left fraction, we have 1 is all that's left in the numerator of the left fraction, times pi radians. So 1 times pi radians would be pi radians. Quantity divided by. And the denominator on the left side, the left fraction I have 1 times. On the right side, all I have left is 6. So usually I don't need to, you probably won't see it with the word radians written in the numerator. So 30 degrees equals pi 6 radians. Well, doesn't that make sense? Think about it. If 180 degrees is pi, isn't 30 degrees 1/6 of 180 degrees? So it makes sense that 30 degrees would equal 1/6 of pi, right? And 1/6 of pi is the same thing as pi over 6. Does that make sense? So sometimes you can figure it out in your head without having to do the conversion. All right, there we go. Example 1, sound. Example 2. Let us convert pi thirds radians to degrees. So this is in radians. So I know that I'm going to put pi thirds, the word radians would stay in the numerator. So when I multiply it, I need the word radians to be in the denominator and degrees to be in the numerator, right? So we know that pi radians is equal to 180 degrees. All right, so think about it. Let's see, the words radians cancel each other out. The pi symbols cancel each other out. And could I reduce 180 in 3? Yeah, 3 goes into 3 once, 3 goes into 180, 60 times. So now when I multiply the fractions, I don't have a lot left. The left side numerator, that's 1 times 60 degrees. So just 60, and I can just even put the little degree symbol. In the denominator, I just have a 1 left, so I don't need to write 60 over 1, right? It's 60 degrees. Pi thirds is 60 degrees. You know a shortcut? Sometimes they don't give you radians in terms of pi, but if they do, and they want you to convert it to degrees, shortcut. To convert radians when in terms of pi to degrees. So how many degrees is how many degrees is pi? 180 degrees, right? So shortcut, if you see a pi and you want to convert it to degrees, just substitute 180 degrees for pi. When you're talking about degrees, pi is equal to 180. When you're talking about radians, pi is equal to 3.14. Okay, so that same problem, pi thirds, radians, you just substitute 180 degrees for pi, technically it is pi radians, and then that was divided by 3, that gives you 60 degrees. Now, again, like I said, radians aren't always in terms of pi. Sometimes they will turn pi into 3.14 and write it as a decimal, then you can't go this route. But if it's in terms of pi, which it usually is, then you can do it super fast like that, super fast. Here we go. Example 3. Convert 45 degrees to radians. 45 degrees to radians. All right, so I know the word degrees will be in my numerator, right? So when I convert, instead of having to look at that conversion every time, I know that my new fraction, the word degrees will be in the denominator so that the word degrees cancels, and the word radians will be in my numerator. And we know that 180 degrees is equal to pi radians, right? You could also do 360 degrees in the bottom, but you'd have to put 2 pi in the numerator, right? Because 2 pi is equal to 360, but your numbers are just bigger. So why not just use pi radians over 180 degrees? So I know since degrees is in the numerator, what I multiply it by degrees has to be in the denominator. So my words degrees cancel. Pi does not cancel this time. Can I reduce 45 and 180? Yeah. They're both divisible actually by 45. 45 goes into 45 once. 45 divides into 180 4 times. So I'm left with top left fraction. That's basically, I've got 1 there, right? Everything canceled out, times pi radians. So my numerator, I'm left with pi. I'm going to just write the word radians. I'm not going to write it in the fraction. In the denominator, I have 1 times 4, and everything else is canceled out. So pi fourths radians. Does that make sense? If you have a 45-degree angle, 45 and 45 is 90, plus another 45, 45, you get to 180, right? So 45-degree angle is 1/4 of a semicircle, or 1/4 of 180 degrees. So that makes sense. That 45 degrees will be pi fourths radians. So kind of start to click. I hope. All right. Y'all do this one. Example 4, negative pi halves radians. So remember, if the word radians is written to the right of the fraction, it's technically in the numerator. To degrees. Forgot to write the word convert. Convert negative pi halves radians to degrees. Y'all do that one on your own. Which I'll get. Negative 90 degrees. Doesn't that make sense? We know if we have a unit circle, right? And we know if it's negative radians, we know that means we're going clockwise. So that means that negative 180 degrees would be negative pi, right? Well, half that would be negative pi halves. So we already know that that would be at your negative 90 degree mark, right? So it makes sense. But if we're using the formula, which is what I wanted you to do, since we're radians, the word radians is in the numerator. So my conversion, the word radians needs to be in the denominator, and I'm converting that to degrees. So my conversion, we know that pi radians is equal to 180 degrees. Again, I could use 2 pi radians and 360 degrees. That's the conversion. Like, you know how when you convert, I said I was going to say feeters and meat, but not feeters and meat. Meters and feet. There's a conversion. Well, we're converting radians to degrees. There's a conversion. So you want the words radians to cancel. The pi's cancel. And I can reduce because 2 divides into 2 once and 2 divides into 180 90 times. But don't forget, you also have that negative sign. So you have negative times 90 degrees. That's all you have left. If the denominator is just 1, we don't need to put negative 90 degrees over 1. So there we go. Boom. Preguntas, comentarios, preocupaciones, ¿sí o no? No? Okay. Do this one. I said questions, comments, concerns in case you were not sure. Convert. Negative 45 degrees to radians. What did you get? Negative pi fourths radians. Anybody else get negative pi fourths radians? Exactly. Good job. So I set up my conversion already. Words degrees cancels. The pi does not cancel. I can reduce 45 and 180 because 45 divides into both evenly. So 45 divides into 45 once. 45 divides into 180 4 times. So when I multiply in my numerator, I have negative 1 times pi radians. So that would just be negative pi radians. And the denominator, 1 times 4 is 4. Negative pi fourths radians. Everybody cool with that? Do you think you're going to remember how to do this tomorrow or be able to look back at your notes to refresh your memory? Or do you want me to give you an assignment so you can practice? You need an assignment? No? You're sure? Okay. So tomorrow, what we're going to do is we're going to take a whole unit circle, okay? And we are going to find the degrees of every angle on the unit circle. We're going to find the ordered pairs of every angle on the unit circle. And we're going to convert the degrees to radians of every angle on the unit circle. It's going to look like this when we're finished. And you'll see it eventually. Oh my gosh. And you're going to memorize it. What? Trust me, it's not as bad as it seems. There's a pattern. You'll figure it out. But tomorrow, we're going to take the 30, 45, 60, 90, 120, 130, etc. All those degrees, we'll label them. We're going to convert them all to the unit or to our radians. And then what we learned last class, how we learned how to find the ordered pairs of each angle, we're going to do that for the whole unit circle. All right? And you're going to want to memorize it. Listen, in pre-calculus, I don't time you. Okay? You can figure it out. You can either memorize it, you can do all the math, whatever. But when you get to calculus, they make you have it memorized and be able to complete this whole thing in 5 minutes. Yeah, but there's a pattern. Don't stress. We'll figure out the pattern, and you'll be able to do that. And they do that because you need to be able to convert all this stuff in your head. You need to have it memorized. You can do it like that. So you don't have to draw out the circle each time, put the triangle in it, do the conversions, and all that stuff. You just know it. Because you use it, and trust me, we will use this so often that most of it you're just going to know anyway. Okay? So I didn't tell you that to stress you out. I just wanted to see what it looks like, and that by the time we're finished, you're going to be like, oh, yeah, it's really not that bad. It looks crazy, but it's really not that bad. Okay, so we'll do that tomorrow. And today it's only 11:07. But we're finished. So at home, if you would like, we'll just log off. There's no need to stay on. We're not doing anything else. So I will see you all tomorrow. If you haven't submitted your homework, don't forget to do that. Okay? And so I'm going to log off, and we will see you all later.